Count how many times the word moon is said in this video. Enjoy! There might be moons out there in space. These are moons orbiting other moons. Online, these fascinating hypothetical space objects have already been nicknamed submoons, grand moons, moonitos, moonates, and even moons. They might not exist in our solar system or any other. But some astronomers claim that the concept of a moon bringing up its own baby moon is quite plausible. The thing is, in all planetary systems we know about, natural satellites occur in a strict order. Planets orbit stars, and moons move around planets. But then, why can't submoons orbit moons? Take Earth's natural satellite. It's so massive that some astronomers even want to call it a planet in its own right. Then why shouldn't this planet-sized moon have its own satellite? In a new paper, a couple of researchers looked for a mathematical answer to the puzzle of moons. Using special equations created to show the tidal effects of planets on their moons, the scientists determined that submoons could exist if the host moon was massive enough and the submoon was small enough. Plus, there should be a wide orbital gap between these two moons and the host planet. This way, a 6-mile-wide submoon could only survive moving around a 600-mile-wide moon on a wide separation orbit. If these parameters are not met, the tidal forces of the host planet would be too powerful and would smash the moon and the moon together. Or these forces would be too weak to keep the submoon, and it would get jettisoned into space. Based on these conditions, there are quite a few natural satellites in our solar system that could hypothetically host baby moons of their own. These could be Saturn's moons Titan and Iapetus, Jupiter's satellite called Callisto, and our moon. Yes, our own moon could have its own tiny satellite. Why doesn't it? The researchers haven't found the answer to this question yet. The existence, or lack thereof, of moons may shed light on satellite formation and evolution in planetary systems. But once we find the answers we're looking for, the next logical question may arise. Can a moon have a moon of its own? If so, what name would be the most suitable for such a space body? A great grand moon? Write your variants in the comments. Besides hypothetical moons, there are loads of other bizarre things in the universe, the existence of which we haven't proven yet. Hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but according to estimates, it could only happen if you applied 10 billion times the pressure you'd need to shatter steel. Then, there's dark matter and dark energy. We kinda know these things exist, but no one has seen them yet. Everything on Earth, and everything people can observe in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite. It was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It was dubbed dark energy. As for about 27% of the remaining universe, it's believed that it's made up of dark matter. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It's dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise, scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic, galaxy-sized black holes.
There are a few theories about how the moon appeared in the sky, and recently a new idea has popped up. But before we discuss this newcomer, let's look at the most popular hypotheses of the moon's formation. The capture theory claims that Earth's natural satellite used to be a wandering body, something like a large asteroid. It had formed somewhere else in the solar system before it was captured by our planet's gravity when passing nearby. The accretion hypothesis suggests that the moon formed in orbit around Earth at the same time as our planet appeared in the darkness of the cosmos. Then, there's the fission theory that says that at one point in its development, Earth was spinning so fast that some of its material broke away and started to orbit the planet. And the giant impact theory, which is the most popular these days, claims that the moon formed during a collision between Earth and another hypothetical planet called Theia, which was way smaller, probably the size of Mars. The resulting debris collected in an orbit around Earth and formed the moon. And now, let's move to the new theory you've been patiently waiting for. According to it, our satellite might have formed immediately, in a matter of hours, after the collision between Earth and Theia. The material from the two planets was likely launched directly into Earth's orbit right after the impact. It formed the moon and left traces deep inside Earth. In previous scenarios, Theia's remains were thought to have been scattered all over space, mixing with just a bit of the material coming from our own planet. But then, why do we see such shocking similarities between the moon's and Earth's compositions? Could it be that Theia was isotonically and chemically similar to Earth? Unlikely. But according to the new theory, more material from Earth was used to create the moon, its outer layers in particular. It might explain this similarity in composition. One more theory also tries to explain this mysterious similarity, the synestia model. According to it, our satellite formed inside a swirl of vaporized rock left by the collision. But this theory can't explain the moon's current orbit. The new single-stage theory does offer us plausible explanations for both the similarities in composition and the orbit of the moon. It might also provide us with some answers to previously unsolved mysteries. Since this scenario puts the moon into a wider orbit and gives it an interior that is not fully molten, it can explain the satellite's tilted orbit and thin crust. In any case, to confirm one of these theories, we need to analyze future lunar samples that will be brought to Earth by NASA's upcoming Artemis missions. Scientists will be able to get their hands on some material from deeper beneath the moon's surface and compare if real data matches these simulated scenarios. In the past, the Apollo missions already brought back about 1/3 of a ton of rock and soil from our satellite. These samples showed that Earth and the moon had some remarkable chemical similarities. They could only suggest one thing. These space objects had a linked history. If the moon had formed elsewhere and been captured by our planet's gravity later on, its composition would be very different from that of Earth. But if the moon had been created at the same time as Earth, or if it had broken off our planet, the type and proportion of minerals on the moon would be the same as on Earth. But they are a bit different. The moon's minerals contain less water than their terrestrial counterparts. The satellite is also richer in materials that form rapidly at high temperatures. That's why the most accepted model of the moon's formation these days is the giant impact model. Meteorites coming from the moon are a great source of data for studying the origins of our satellite too. They can tell us even more about the moon than Apollo samples, all because such meteorites come from all over the surface of the moon. Meanwhile, Apollo samples were collected just in one place near the equator, on the near side of the moon.
You hear some noise in the street and rush up to the window to check what caused it. You look up at the sky and just stand there, speechless. The moon is giant. It looks much larger than usual, and it's both beautiful and scary. So what would your life be like if the moon moved twice as close to Earth as it is now? Unfortunately, it would be quite a catastrophic scenario. You see, the moon has a pretty strong gravitational pull on Earth's oceans. It produces 2 high tides and 2 low tides per day. But with the moon so close to us, the tides would get 8 times higher. Some regions would be completely covered with water during the day. The water would only retreat at night. Many islands and highly populated coastline territories would become uninhabited because of this. Many other regions would experience frequent devastating floods. But if you think it would be the only consequence, let me tell you this. The moon also has a tidal effect on dry land. That's why if our planet's natural satellite was to suddenly relocate, its gravitational pull would increase, making waves of energy reverberate throughout the planet. This would affect Earth's crust, triggering earthquakes and starting volcanic eruptions. Now let's leave Earth and the giant moon for a while and have a look at Jupiter's moon, Io, which is the most volcanically active world in our solar system. This volcanism comes from the push and pull from Jupiter's gravity. Two other moons of the gas giant also have an effect on poor Io. That's why Io's surface is littered with hundreds of volcanoes. Most of them are spewing sulfurous plumes high above the surface of the moon. Our planet might face the same fate should the moon move so close to it. And that's not all. Earth's spin would start to slow down over time. Look, the moon's gravity pulls the oceans, and the resulting friction between the water and the ocean floor slows Earth's spin. Yes, Earth is slowing down even now as you're watching this video, but this process is almost imperceptible, around 1/1000th of a second per century. If the moon was twice as close to us, the rotation of our planet would slow much more, making days and nights longer. If people managed to survive unexpected earthquakes, high tides, and volcanic eruptions and got used to longer days and nights, they would get an award. Solar eclipses. These spectacular events that occur when the moon passes between the sun and Earth would happen much more frequently. Since the moon would cover a much larger area in the sky, it would pass in front of the sun more often. People on Earth would be able to see the sun's outer atmosphere, called the corona. It would shine beautifully around the silhouette of the moon. Such solar eclipses would also last much longer. But what if the moon didn't shorten the distance overnight? What if it was a much slower and much more gradual process? Then our planet's crust would shift more slowly. Tides wouldn't change so dramatically either. This would let living creatures on the planet get used to the new conditions and adjust in time. Longer days and nights would likely change the climate, and animals would have to evolve to adapt to it. Their eyes would have to change to be able to deal with brighter moonlight at night. Prey would have to learn to hide better, but predators, on the other hand, would have more advantages when hunting. But what catastrophe would have to happen to make the moon move so close to Earth? Well, it could be some massive object, like a giant asteroid passing very close to the Earth-Moon system. If the moon was in the way of this space traveler, it could take energy from Earth's satellite, which would cause the moon to spiral towards our planet.
Imagine stepping out of your spacecraft and setting foot on the surface of the moon. Under your feet, the ground is covered with a fine material that looks like powder. That's lunar dust. You look around and take a lungful of fresh air. It smells very different from the air on Earth, but still nice. Now, unfortunately, this is a highly unlikely scenario, and one of the reasons is that the moon has almost no atmosphere. Earth's natural satellite is too small, less than 2% of our planet's mass. That's why it doesn't have a magnetic field strong enough to keep an atmosphere. But even if the moon had it, solar winds would immediately pull it away. But if you could visit the moon 3 or 4 billion years ago, you'd see a very different picture. At that time, the moon most likely had an atmosphere. It formed at the times when powerful volcanic eruptions were rocking the satellite. Gases spread all over the moon's surface. It happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurling high into the air, falling to the ground, forming lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists on Earth got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggested the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days it's around 240,000 miles. That's why the Moon looked much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. Neither was I. At the same time, the most recent studies have confirmed that our Moon actually does have an atmosphere. It's composed mostly of hydrogen, neon, and argon, and contains some very unusual gases, like potassium and sodium. You can't find them in, let's say, the atmospheres of Mars, Venus, or Earth. Sadly, such an atmosphere isn't suitable for us oxygen-dependent creatures. But guess what? There's loads of oxygen on the Moon. I know, it must sound confusing, but the thing is, this oxygen isn't in its most common gaseous form. It's trapped in a layer of rock and dust covering the surface of the Moon. This layer is called the regolith, and it contains up to 45% oxygen. So, does it mean that if people learned how to extract this oxygen, we would be able to live on the Moon? Not so fast. The oxygen in those rocks is very tightly bound into the minerals, and to break these components apart, we'd need tons of energy and special equipment. But if people managed to start this process, the Moon would deliver quite a lot of oxygen. Now, there's a theory that the Moon might have been formed during a collision between Earth and another planet. This planet must have been smaller, the size of Mars. It probably happened around 4.5 billion years ago. Another theory claims that the Moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet, and that's how the Moon appeared in the sky. And the least exciting theory claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. These days, the Moon is the 5th largest natural satellite in our solar system. It's also one of the densest, second only to Jupiter's satellite Io. Most likely, the Moon has a tiny core, no bigger than 2% of the satellite's mass. About 420 miles wide, it consists mostly of iron and sulfur. The Moon's surface is dark, even though Earth's natural satellite is the brightest object in the night sky. But in reality, its reflectance is just a bit higher than that of asphalt. You might have heard that the Moon, along with the Sun, causes tides in the oceans and seas on Earth. The satellite's gravitational pull creates something called the tidal force. It makes the water bulge out on the sides that are the closest to the Moon and farthest from the satellite. These bulges are what we know as high tides. But what not so many people know is that the Moon also causes rocks to rise and fall, just like it does with water. Of course, this effect doesn't look as dramatic as ocean tides, but it's still noticeable. Earth's solid surface moves by an inch or so with each tide. Now, not only does the Moon cause tides on our planet, but it also slows down its rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The Moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. You should really cut those. If one day it floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the Moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Since the Moon doesn't have an atmosphere, nothing protects it from extreme temperatures. It gets incredibly cold on the night side, minus 390 degrees Fahrenheit. Meanwhile, the sunny side is literally boiling, with a temperature of 250 degrees Fahrenheit. Another thing the moon can't protect itself from without an atmosphere is meteorites. That's why the surface of the satellite is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. The moon is less seismically active than Earth. That's why these craters and other ancient formations stay in perfect condition for centuries. But even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. They start several miles beneath the surface. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say the moon has become around 150 feet skinnier than it used to be several hundred million years ago. So, how does it work? Well, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike a grape, the moon doesn't have any flexible skin. Its surface is hard and brittle. So, as the moon gets smaller, the crust cracks and breaks. Its sections get pushed over neighboring parts. Researchers are sure that such faults are still active and likely responsible for the quakes shaking the moon. Some of these quakes are pretty strong, up to 5 on the Richter scale. When you look up at the moon, you always see the same side of Earth's natural satellite. Like our planet, the moon rotates around its axis, but this rotation lasts around 27 days. This is the same time the moon needs to orbit Earth. Such a phenomenon is called tidal locking. Before space exploration started, people had never seen the other face of the moon. They didn't know what the far side looked like. While the near side of the moon is mostly large plains covering impact basins, the far side is rugged and cratered. The crust is thicker there, with less evidence of volcanic activity. Oh, by the way, the moon isn't perfectly round or spherical. It's shaped like an egg. When you're looking at it, one of its small ends is always pointing at you. Yep, right at you. This is the reason why the moon's center of mass isn't its geometrical center. In reality, it's a bit more than 1 mile off-center, like a poorly made golf ball. Now, you wake up one morning and watch the news while having your morning coffee. They did it again! Those scientists! The news anchor yells on the TV. A report was released a few days ago that the moon is moving further away from Earth's orbit. Its distance extends 2 inches per year. Over the past 2,000 years, it's drifted a total of 260 feet. This isn't too daunting of a distance, but the news has still made people panicked and concerned. They rally together around the planet, uniting to try and stop the moon from escaping Earth's orbit, even though it won't actually leave the orbit for over 1 billion years. But everyone was focused on the past benefits of the moon. It's obvious life on Earth as we know it wouldn't have evolved without its existence. The moon is controlling the tides and the molecules in the atmosphere. Without it, humans, in particular, wouldn't have evolved. So, with an appreciation of the moon, the top brass ordered the best scientists to come up with a solution to push the moon closer towards the Earth. A giant thruster engine was built on the dark side of the moon. It was ignited, and the thrusts tried to push forward, but the startup power wasn't strong enough to push the moon. Instead, it tilted the moon's axis, rotating it slowly. As the moon rotated, the scientists hurried to turn it off before the engine reached its full power, as it was headed off course. The brass didn't accept this and ordered them to continue with the objective. The scientists insisted the math wasn't correct and didn't know exactly what may occur. Their concerns were ignored, and they watched as the engine's power increased. The engine slowly pushed the moon, the distance reducing. But as it was provided at the wrong moment, the angle it was aimed at would provide complications. The thrust and gravity from the Earth ensured the moon followed the orbit at a reduced distance. But with the combination of the initial thrust on an indirect angle, the moon was directed away from the Earth, quickly moving further off its trajectory on a path to leave the orbit altogether. As you finish your breakfast and turn the TV off, you go outside to look at the moon. It sits high above, seemingly fine. Surely, the news anchor was just exaggerating. You go to work. The issues of the moon are now just an afterthought. Even if it was true, how could it possibly affect your day? The morning feels normal, just another day at the office, as it turns out. During your lunch break, you head into town and notice on your way that the wind is picking up, getting stronger and colder. It must be a storm approaching. You quickly check on the moon. It appears smaller, about half the size of what it was this morning. But it's midday, so it's supposed to be that size, isn't it? After you finish your meal at the restaurant, you leave to find it's becoming darker. The wind is much stronger than earlier, but there are no storm clouds in the sky. People in the streets are pointing towards the sky, shocked at something, probably an eclipse. As people begin running in the streets frantically, you look above and can't see the moon. Confused by everything, you decide to head home for the day. When you arrive home, you turn on the TV. The news anchor, who is now more serious than earlier, explains that the moon has left the Earth's orbit altogether and is flying off somewhere into space. The loss of the moon means the daily cycle has changed. Now, there are only 6 to 12 hours of sunlight a day and over 1,000 days per year. I only have to work half as much, you say excitedly, pumping your arms in the air. The lack of the moon creates a completely different world. The pull of the moon's gravity is what keeps the Earth in a place at 23.5 degrees angle, ensuring the weather patterns and normal days that we're accustomed to. Baffled by all the scientific information, you go outside to just confirm you aren't being pranked. The shorter working week seems too good to be true. As you look out into the sky, you notice the stars are brighter than you have ever seen. You can clearly see the outline of the Milky Way's arms. The stars are far more numerous than you remember, with Venus glowing far brighter than them all. It's a beautiful sight, but you're not sure whether a clearer night sky was worth the moon's removal. You have never been interested in astronomy. You decide to go to bed. It's a good idea to adjust to the new night and day cycle. You set your alarm for 2 hours. That should be enough, you say to yourself happily. Tomorrow is Saturday, after all. You need to get up early to go surfing. Gotta catch those high tide waves. You wake up, get your things together, and drive to the beach. The news on the radio explains some issues about how the Earth is now more defenseless to asteroids without the moon. Then they talk about some issues with the tides. Something about how the tide is now 1/3 the size it used to be before. You're unsure how this could affect the waves. Maybe it means they will be larger. You park at the beach, grab your board, and look towards where the surf should be. It should be high tide, but the sea is somehow a lot further away than normal. You shrug off the hurdle of having to walk towards the water. After a long, enthusiastic walk toward the gnarly waves, your mood changes as you approach, staring blankly at the tiny waves. Upset, you head home. While driving, you listen to the news and pay more attention to the information provided. In place of structured seasons, there are only erratic weather patterns. Winds are faster and stronger, creating more powerful storms, and in some places, there are just stagnant conditions. The equator is no longer always warm. The poles aren't constantly cold. The depths of water shrink. Tides only adjust to the sun's gravity, reduced to 1/3 of the pre-moon depths. Throughout the world, the seas change in altitude, shrinking at the poles, and the bulge of water around the equator shifts. The moon regulated the tides and provided the periodic changes that were a key element to assisting with life on Earth. Aquatic life forms are displaced within shallows worldwide. Life cycles of important microbial life have been upset. You couldn't imagine that something as simple as a change in the tides could be so important to billions of life forms. Water and precipitation, which is distributed across the globe, cannot provide sustenance where they did before. The weather has become more extreme, hotter for longer periods and colder for other parts of the Earth. Over time, some thousands of years in the future, dry deserts will transition into ice ages. These intense changes disrupt the natural order of all things for life on Earth. Not only did the moon control the tides and weather, but it used to pull molecules within the atmosphere as it moved. The now constant movement disrupts molecules, creating barriers for future evolution. You arrive home, upset after learning the disheartening news. Not only will you never be able to surf again, but all life on Earth will change. An age of devolution has begun. Over the next year, flora and fauna change to adjust to this new world. Migratory animals that would travel toward greener pastures find nothing at all. Birds are completely confused, with no end to the change in seasons. Hibernating animals delve in and out of their shelters at the incorrect times, and vegetation struggles to grow at the lack of sunlight. Nocturnal animals cannot see without guided assistance from the reflection of the moon. Although Venus is the brightest source of light when it's dark, it's only 1/1000th of a fraction as bright as the moon was. Predatory animals that hunt during the night are not capable of finding their prey, providing an opportunity for smaller animals to thrive. Although life on Earth has changed, it will continue to exist. But the sudden adjustments will become a test for all walks of life. Over time, it will be very interesting to see what species have adapted and evolved. A world where rats and mice would be more prominent due to their adaptive capabilities could create a new dominant species to emerge. In millions of years of evolution, their descendants will primarily flourish. We could see buffalo-sized mouse herbivores crossing the plains and tiger-sized rats roaming within the jungles. Tree-faring mice with long arms may swing amongst the branches. Others will probably move to the seas in place of mammals to feed upon aquatic life. Wide-eyed predatory rats may occur to have similar traits to bats, with echolocation, becoming the conquerors of pitch-black nights. All the new species that will emerge, undoubtedly, will continue to be monitored by humans, wherever we may be.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time.
Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced, and the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the Kraken or Leviathan there, or weird glowing fish with 2 heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. there might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes.
A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. Mathematicians claim white holes might exist. Unfortunately, scientists haven't found one yet. Even if you saw a white hole, you wouldn't be able to enter it from the outside, but you'd notice light and matter leaving it. Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could already be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness in April. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. Our Milky Way galaxy and the Andromeda galaxy, our closest neighbor, are going to meet. But it'll happen in about 4 billion years. When they collide, an enormous elliptical galaxy will be formed. There might be more water on the moon than scientists thought before, and not only on its dark side, but also its sunlit side. This water is likely to come in handy during the already planned missions in the future. Cotton candy exoplanets are particular planets outside of our solar system, also called superpuffs. They have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, these planets are enormous. The Juno mission has noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet. These are 2 kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at a height of 60 miles above massive thunderstorms. In the universe, there are not only dwarf planets, but also dwarf galaxies. They have from 1,000 to a few billion stars. For comparison, the Milky Way galaxy is made up of 250 to 400 billion stars. A storm the size of our planet keeps raging on Saturn. It's called the Great White Spot. The storm has a tail of white clouds, and it encircles the entire planet. The storm occurs every 30 years or so, when Saturn's northern hemisphere tilts toward the sun. At first, the storm is indeed just a spot, and then it starts stretching in length. That's because the Great White Spot is a huge system of thunderstorms. But the main mystery puzzling astronomers is where the storm gets its energy from. Some scientists think it might be powered by the sun. Others disagree. They say the storm's cloud pattern only makes sense if there's an internal heat source that can power the winds. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also very hard to find. Rogue planets don't produce light. Neither do they emit heat, which means they can't be seen in infrared light. But not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. The Moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the Moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. Scientists often discover strange things in space. Many of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They aren't the remains of supernovae or a bizarre optical effect. Some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between black holes. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our sun produces in days, but last for mere milliseconds. Most of these fast radio bursts came from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source was a magnetar, just 30,000 light-years away from our planet. Any liquid floating in outer space forms itself into a sphere. This phenomenon also occurs in low Earth orbit. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. Astronomers saw the star for the last time in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in an extremely bright supernova, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. In billions of years, the universe is likely to expand so much that we won't be able to see any stars in the sky. All planets in the solar system emit radio waves. They're especially strong if we talk about Jupiter. This planet has the biggest and most powerful magnetic field. But astronomers couldn't detect any radio waves coming from a planet outside the solar system. That is, until 2020. The signal scientists recorded came from a gas giant, Tau Bootes. It's 51 light-years away from our planet. Thanks to this signal, astronomers managed to find out a bit about the planet's magnetic field. And in the future, this will help to learn more about what's happening in the planet's atmosphere. Dwarf planet Haumea is further from Earth than Neptune. It's orbiting in the Kuiper Belt. That's a donut-shaped ring of ice objects circling the sun. Elongated Haumea has 2 moons. A day on this dwarf planet lasts 4 Earth hours. All in all, this space body is rather bizarre. It's surrounded by thin rings that likely appeared as the result of an ancient collision. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf. and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees Fahrenheit. That's hot enough to melt some metals. China's Yutu-2 is a robotic mission to the dark side of the moon, launched on December 7, 2018. On January 3, 2019, it completes the first ever soft landing on the lunar far side. It lands in the von Karman crater, not far from the moon's south pole. Scientists are interested in this area. Cold, permanently shadowed craters at the poles contain water ice. These ice patches are uneven and are likely to be ancient. In the south, most of the water ice is concentrated in craters, and at the North Pole, it's spread more sparsely. In any case, this ice can be used once a long-term manned mission lands on the moon. Anyway, several days after Yutu-2 lands, it closes down its operating systems and hibernates through its first lunar night. It wakes up on January 29, 2019. All its tools operate normally. The rover travels 390 feet during its first full lunar day. One lunar day lasts for about 14 days, and a lunar night has the same duration. Moving and exploring during the day and switching off during the night becomes the rover's routine. It's the 8th lunar day when Yutu-2 stumbles across something incredible. This discovery makes the scientists put off all other plans for the mission. They focus on figuring out what the strange material found by the rover is. In the beginning, this lunar day is no different from any other. It begins on July 25th, when the rover starts making its way through an area pockmarked with tiny impact craters. Yutu-2 is helped and monitored by the driver team from the Beijing Aerospace Control Center. On July 28th, the team is preparing to shut the rover down for a midday nap. The sun is high in the sky. It means there are high levels of radiation and scorching temperatures that can damage the machine. Before powering Yutu-2 down, the scientists are looking through the pictures taken by the rover's main camera. That's when they spotted a small crater filled with something that looks shockingly different from the surrounding landscape. Unable to identify the gel-like substance, the team orders the rover to check this bizarre finding. Yutu-2 cautiously nears the crater to examine the weirdly colored stuff. The machine uses special equipment that detects the light reflected off the substance. It's supposed to help the researchers to understand the structure of the material. Unfortunately, the nature of the unusually colored finding has remained a mystery for over a year. No wonder that both the finding and the fact that initially there were no images of the enigmatic stuff sparked curiosity all over the world. The only available description of the substance was that it looked like a randomly colored, shiny gel, something that's rather odd for the dusty, arid surface of the moon. But finally, the mystery seems to have been solved. The researchers have analyzed the information received from the rover's equipment. As expected, the substance turned out to be made up of rock, greenish and glistening breccia, in a sample no larger than 20 by 6 inches. It's kinda like a geologic version of Jell-O salad with fruit inside. If you melt it down, it'll look glassy. Breccia consists of sharp stones joined together by a chalky substance. The sample found on the far side of the moon is made up of a mix of different minerals. The main is a type of silicate that's one of the most common components in both the moon and Earth's crust. The piece also contains some glass, which means it could have formed during a volcanic eruption. But volcanic activity on the moon stopped more than 3 billion years ago. That's why the researchers are almost sure it's unlikely to be the source of the unusual finding. The material could have been created by a massive asteroid, comet, or meteorite that once hit the moon. During the collision, the pressure and temperature were so high that huge amounts of rock instantly melted. Some pieces cooled down rapidly enough to form glass. The rest gathered at the center of the impact crater and grew colder more slowly, forming a new rock. The substance was likely not formed in the Von Karman crater, but in the nearby Finsen and Alder craters. The hollow where the rover made its finding was just 7 feet across. Whatever left it had to be no wider than an inch. But then, it would be too small to create such a large piece of breccia. It's interesting that the material is similar to the samples collected by the astronauts from NASA's Apollo missions. One of those samples was made of dark, broken shards of minerals glued together. It also contains some black, shiny glass. It's not clear, though, whether it's the same as the stuff discovered by U-22. When the rover took photos and made its measurements, it was rather dark in the area. The quality of the images isn't that great. The experts also explain that the mission is examining a previously unexplored area of the moon. That's why they don't have any samples from that region to compare them with the greenish, shiny substance U-22 found. But if their guesses turn out to be true, then the far side of the moon might have more in common with the Earth-facing one than we used to think. But what's so special about this dark side of Earth's natural satellite, and why can't we see it? It's all because of the phenomenon known as tidal locking. Earth's only natural satellite rotates around its axis once in 27 days. It's the same amount of time it needs to go round our planet. That's why you always see the same face. To be precise, 59% of the moon's surface is visible to people. It means that you can catch glimpses of the satellite's far side at some times of the year. The moon's side we can't see is quite different from the one facing Earth. It doesn't have dark spots that are visible at night. Those are lunar basaltic plains called lunar maria. They were created by ancient volcanic eruptions. Those happened about 3 to 4 billion years ago. Instead of plains, the far surface of the moon has countless craters and tall mountains. One of the ideas about such a striking difference between the two sides is based on the collision theory. It claims that billions of years ago, Earth collided with another planet or some other massive space body. After that, the debris from this collision crashed with something that would later form our moon. That's why the satellite's landscapes differ so greatly. A more recent theory suggests that the Earth-facing part of the moon is warmer because of the heat radiated by our planet. During the period of volcanic eruptions, it was cooler on the farther side. That's why the minerals there became solid faster. They formed a protective layer shielding the moon's insides against the meteorites. But each impact left an impressive crater. At the same time, a much softer crust on the front-facing side of the moon spewed lava every time a meteorite hit it. After this lava cooled down, it covered the impact craters. Even though the far side is often called dark, both sides get almost the same amount of sunlight. The side we see looks a bit brighter because of the glow coming from Earth. There are 2 reasons why people are interested in exploring the far side of the moon. After leaving our planet, many radio waves get blocked by Earth's natural satellite. If astronomers could build their radio and optical telescopes on the dark side, they would get much more data. There would be no problems with any kind of interference. The telescopes would also be shielded from the glare of daylight coming from our planet. If telescopes were set up inside craters, they would also be protected from solar radiation. Astronomers would be able to get an incredibly clear view of the far regions of the universe. Plus, scientists believe there are great amounts of helium-3 on the opposite side of the moon. Earth is protected from solar winds that carry this gas by its magnetic field. But our natural satellite doesn't have such a shield. That's why experts believe the moon can be a perfect place for helium-3 mining. This rare element can be later used as the fuel for fusion reactors. Look up. Find that little yellow dot. That's Titan. It's Saturn's largest moon and the second largest moon in our whole solar system. And it might be the only place in our solar system where there's liquid water, besides Earth. Plus, it has an atmosphere that serves as a shield against solar radiation and cosmic rays, just like Earth. If life was a house, Titan would have a lot of the bricks you'd need to build it. Strap in, you're heading over there. It takes a long time to get to Titan, but you know, the magic of YouTube. Here it is, a bit bigger than our moon and a whole lot heavier. It's even bigger than Mercury. That means its gravity is still pretty weak. You'll feel 7 times lighter here than on Earth. At the local gym back home, you can lift 150 pounds. On Titan, you can lift more than 1,000. Ha! Looking good. The surface is mostly made up of ice. It has small mountains, craters, and a few cryovolcanoes. Basically, the same as a regular volcano, but instead of lava, this beast spits out water, ice, ammonia, and methane. There are lakes and clouds, kind of like a canyon would look like on Earth. But here, there's only a tiny difference. Everything is covered in thick fog, and sometimes it hails frozen methane. On Earth, we use methane as fuel because it burns. But on Titan, there's no oxygen. Can't get a fire going on this hunk of rock. No oxygen means you need to put on an oxygen mask, but you don't have to wear a whole spacesuit like on our moon. Titan has a stronger atmosphere, but you packed a sweatshirt, right? It's gonna get pretty cold soon, like negative 300 degrees cold. The coldest it ever got on Earth was negative 128, and that was right at the South Pole. It's so cold because it's so far from the sun, almost 900 million miles. Anyway, that dense fog and atmosphere stop the sun's rays from warming the surface. Sounds kind of extreme, but so is life. It can survive almost anywhere. Take the bacteria Dano, some long Latin word. It can survive radiation and extremely low temperatures. It even survived a whole year in outer space, on the outside of the International Space Station. Titan would be a piece of cake compared to that, especially if we drilled down a bit. Many scientists believe there's a whole ocean under the surface of Titan. Saturn's gravity gives Titan's core a little heat boost. Plus, there's ammonia in that ocean. It's like Titan's version of antifreeze. As long as the water stays liquid, life's got a pretty strong chance of success. So what's down there? Scientists have actually found real evidence that Titan might already have life on it. Here, check out this microscope. This is C3H2. It was discovered by this weird group of antenna things living in the desert in Chile. It used 66 antennas, all pointed at the same place in the sky. This C3H2 molecule can act as a building block for DNA, the code of life. Some people think that these molecules were around on our planet billions of years ago, just when life began. Scientists also checked it out firsthand with a probe that actually landed on Titan. Turns out those desert antenna things were right. Titan shot to the top of the list of places we could one day live on. Sorry, Mars. NASA has a new project, the Dragonfly mission. They're gonna send a drone out there and explore Titan even more. The mission's still about 6 years away, and the rocket will reach Saturn's moon 9 years after that. So we're gonna have to wait a while before we pack up and move to Titan. After the Dragonfly drone lands on Titan's surface, it's going to whiz around like a sort of double helicopter. It's going to have 8 propellers, 3 feet wide. Since there's weak gravity, that's more than enough to give the drone good cruising speed. It'll be able to fly about 2 miles straight up and take off and land vertically, like a regular helicopter. The main problem with the whole thing is the drone's batteries. Scientists invented a generator that converts thermal radiation energy into electrical energy, whatever that means. One battery charge should be enough for several hours of continuous flight. The Dragonfly is going to be carrying a lot of research equipment, so it's not like those drones people fly in the park on a Sunday. It's going to weigh about as much as 3 ostriches. It's going to have 2 drills, a bunch of sensors, a spectro thing to find out what chemicals are lying around, and it's also going to have its own weather channel with a ton of instruments to measure temperature and clouds and stuff. And like any gadget nowadays, it has a camera on it. Get ready for some beautiful pics of Titan's epic landscape. Nighttime on Titan lasts about 8 Earth days. That's when the drone's going to be relaxing on the surface, recharging and analyzing samples. That's a long time, but it's actually a good thing. Titan's distance from Earth causes a bit of a problem, a delay in communication. When they send the Dragonfly a signal from Mission Control, it has to fly halfway across the solar system. It takes over an hour. In contrast, the signal delay to Mars can be as little as 10 minutes, and the signal delay to the Moon is only about a second. Scientists expect Dragonfly to provide more information about whether we can live on Titan or not. Some experts hope to find a primordial soup there. It's a whole mush of stuff needed to make life. We had that same soup on Earth about 4 billion years ago, and every single living organism that ever existed evolved from this mush of organic elements. If the Dragonfly project's a slam dunk, and Titan does turn out to be habitable, it'll have one more mission: to find a nice place for us to settle down in. But creating a self-sustaining colony on another planet would definitely be the hardest thing humans have ever done. First hurdle: energy production. Probably some sort of nuclear power plant. Then comes shelter for humans and their machines. Those new Titan buildings will have to protect us from the extreme cold and bad weather. Then, drinking water and oxygen. We'd need to invent a way of collecting or engineering both. Then, greenhouses for growing food. We'd also need to mine fuel for transportation. Luckily, Titan's packed full of methane, which is great for fuel. One huge problem: gravity. Because it's so weak on Titan, whoever lives there could lose a lot of muscle mass, making it hard to work and even just live. And there are those pesky cryovolcanoes shooting stuff out at random times. Or maybe we'd need a more drastic, daring idea. How about changing Titan's atmosphere so we can breathe on it and not have to wear about 100 hats and gloves? To do this, we'd need to terraform Titan's surface for a long time. Titan's atmosphere needs to be enriched with oxygen for us to breathe, and it would be great if it was a bit warmer. The next step is to create a biosphere, which means plants. We could turn Titan into a blooming jungle with plants brought over from Earth. But because of pressure and gravity, they'd look completely different from Earth plants. They might all grow super tall, or maybe they'd all shrink down to mini size. We really don't know. First things first, we need to make sure that life is even possible on Titan. Scientists recently thought there might be life on Venus. It's sort of the same size as Earth, and scientists even call it Earth's twin sister. They discovered a gas on Venus, phosphine. Supposedly, it was made by living organisms. Turns out it wasn't true. Well, not really. There is some phosphine floating around, but way less than we first thought. Look, science on other planets is super hard, people. We're always making mistakes like that. The moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. but it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. A transient lunar phenomenon is one of the most enigmatic things happening on the moon. It's a short-lived light, color, or some other change on the satellite's surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the moon. One of the mission participants noticed that one part of the natural satellite was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. There might be more metals, for example titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would be easier to walk on the moon's surface, but it would be more dangerous too. Your feet inside a heavy spacesuit would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden under the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared in the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. There's no air on Earth's natural satellite, but then how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. But even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. The Earth and the moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The moon creates tides in the Earth's oceans. They pull back at the moon and make it speed up. This, in turn, moves the satellite to a higher orbit. In prehistoric times, the moon was way closer to our planet than it is now. Luckily, we aren't going to lose the moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the moon away with such a force. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several hundred millions of years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface, about 30 miles long and 60 miles wide. The cave's likely to be the result of 3 billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface, discovered by NASA, might be the openings to lava tubes. The moon's orbit around the Earth isn't a circle, it's an oval. That's why the distance between our planet and the satellite varies from over 225,000 miles to more than 250,000 miles. There's very little seismic activity going on inside the moon. Yet, mini moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fractures appear in the satellite's surface, and gases escape through them.